In this lecture, what I want to do is go over the difference between distortion in analog and digital. So the first thing to recognize is that what we're going to be doing is looking at the idea about distortion and how it's going to alter certain shapes. In this case, how it'll alter an audio wave. So what you have to understand is that a sine wave is basically just a pure wave form, as you can see here. And what distortion will do is it will alter the waveform in some way. As you can see in this example here, that distortion will adjust this and it will distort the individual peaks and troughs within this sine wave. What is important to take away from this is that distortion in some way will alter a sine wave or a waveform. So, distortion, one of the examples of this is that it will add a certain sound to a waveform. So we're going to look at this in the analog sense, and using distortion through an analog equipment. So an analog equipment, as a reminder, could be anything from a synthesizer to a mixing board. It's basically a process that isn't very perfect. In other words, it's going to alter the sound in some way by the sound going through this, this analog board. Now, the use of analog boards, what I'm trying to say is that it will modify this sound in some way, and that each analog equipment, being a mixer or a synthesizer, will change the sound or distort the sound in an individual way. So because it's now being modified, it's going to add a bit of distortion, and in some cases it will add what they call overtones in this. And an overtone is basically like a better sound, if you will. So the addition of harmonics, and I'll be going into detail about this in the next few slides, but the addition of harmonics is what I want to emphasize within distortion. So this isn't about just clipping a certain sound, but again, through the use of analog equipment, what we found is that the addition of harmonics is being applied through distortion. Okay, through distortion. One thing I do want to mention, which is this, is that these keywords down here, these definitions, you should now be writing down and understanding what these definitions are. Okay, so I do want to go through what the history of analog. So again, this is all going to be analog rather than digital, and I'll get into digital much later. The first thing to understand is that guitar amplifiers or tube amplifiers were the first ones to apply this distortion. So how this works is basically through a vacuum tube amplification, and basically that the amplifiers were there to make these notes louder. And through this vacuum tube amplification, this was the first instance of an instrument distorting. So as a reminder, that any sort of analog equipment, basically what it does is that it will it'll take a pure sine wave and it'll make it imperfect. And again, what happens is that the audio is sent through these tubes, and what comes out of these tubes will be distorted, which will have harmonics as well. So this is a simple diagram about what happens, just so that you can get a visual of this. So what you do is you first start out with this perfect sine wave. And this sine wave, what it is think of like a guitar's vibrations or a vocals. Those are then being sent into this tube amplifier, and the tube amplifier will distort or change this sound in some way. And as you can see on this last diagram here, that what we have is a clipped sine wave. What I want to bring to your attention on this is, can you notice how on the very tips of these, rather than them being curved, like this perfect one here, you're now having these horizontal lines on the peaks and the troughs. So as a reminder about this, what we have when we have a sound going through an amplifier or like a tube and it being distorted or clipped, it's also going to add these harmonics. So what harmonics are basically they're going to be adding tones above the certain frequency. So all this is really explaining is that you get these overtones. Now, with guitar amplifiers, what they found is that they could now also use this within transistors. So transistors are basically the next point above tube. And what they found was that they could distort a certain sound in a very different way. Okay, so there's a few things that I want to go over first of all. The first one here is you must start understanding what these definitions are, these peaks and these troughs. And another one is a bias point that I want to go over. And basically what a bias point is it's just this middle line here. I won't draw it all the way through. It's just that middle line. Now, when you had a guitar sound and it was pushed through one of these transistors, basically what would happen is that it would distort, and the sound that came out was a more harsh sound and a little bit less warm than the tubes. So what they also found was that if they took this bias point, and again, the bias point is this line that was in the middle here, and what you could do is that you could now move this bias point up or down, and in this case it went down. And what they noticed was that this bias point, when moved down, produced a crunchier or harder sound. And again, this is very, very important that you understand, which is that these peaks here are not distorted at all. However, when the peaks go down and it hits that line, notice how it becomes horizontal. So within this is where the distortion is occurring, which is down here, which is down here, and also which is down there. Now, the opposite of this is also true, that if you had the bias point, and again, I'll just draw that line. So if you had this line here in the middle, that's where the bias point was. If you now move this bias point up, what you're going to get is also a different type of sound. And in this case, what they noticed was that you had a warm or a smooth sound. Again, what I want to bring to your attention is the use of this. This is very, very important. That when a sine wave hits this peak here, and I'll put this in red so you can see, when it hits that peak there, notice how it will go horizontal. And this is very important. Every single time that waveform hits one of those peaks, either above or below, it goes horizontal. So this is just giving you a visual. And I know that there's a lot of information here, but the main thing to take away from this is when a sine wave is clipped, so in this case, in here, it's clipped, and also here it's clipped, as well as on the bottom. When that occurs, notice how I've driven, or I drew in a horizontal line. So this waveform that was going up here, and should go above that line, when it's being distorted, will go now horizontal. And that is very, very important for you to take away from this. And again, notice how in this example that the bias point is directly in this middle. I haven't seen any tests where they ask you about a bias point, but in the future they could. Okay, so again, I just want to bring up about these keywords that we should have in these keywords. Obviously, distortion, harmonics, saturation, and overdrive. So overdrive and saturation is something that I want to talk about in this slide. So what is the difference between saturation, overdrive, and distortion? Well, this really falls into less distortion or higher distortion. So overdrive sits directly in the middle of this. In other words, you're not going to have this like low levels of distortion or like a real crunchy sound. It's going to sit somewhere in the middle of this. Saturation will sit at the lower end of this. So if you don't want to distort your sound too much, but you want that that like warm overtone sound, you're going to use saturation. And on top of this, you also now have distortion. Distortion is what you hear within a lot of like rock music, for example. Okay, so the last thing that I want to mention about this is vinyl distortion. And vinyl distortion came about obviously through vinyl records. What is very important about this slide, and you can pause it and write down all of these things and then come back into me talking about this, is basically that vinyl distortion added harmonics to this, and that the harmonics were found to be pleasing to the ear. So another way to look at this is that vinyl distortion added warmth. And that really is all I want to say in this slide. Okay, so they found it to be pleasing, this vinyl distortion, because it gave sounds a certain warmth to them. And again, this is all analog equipment. So within that, what I now want to do is dive into digital distortion, which is going to be going into zeros and ones, because that's the digital world that we live in. So again, I just want to point out to you that you should have all these keywords down. We're going to be going over bit crushing in this slide. Okay, so you have two possibilities for distortion. One is that they're going to exploit, as I've said here, about exploiting the use of moving from analog to digital, and this is what is called bit crushing. So they're going to, again, this is very, very important, that they're going to exploit that idea of, again, an analog sound moving into digital, and this is called bit crushing. The next one is about emulating, and emulating is taking that sound, that like overtone sound, and moving this into what they call wave shaping. So these are two different types of distortion when you move from the analog world into the digital world. Okay, so going back to the digital, how a computer will read information or sound, this is very, very important, that a computer reads everything within a bit, and a bit is basically defined as a 0 or a 1. And to store all this information, all they have to do is to basically convert all these analog sounds into digital bits. And again, a bit is either going to be a 0 or a 1. So really two things must happen during this process. The first is that we have to take regular intervals or regular measurements in certain intervals, and also that you need to have a snapshot, if you will, using these bits. And again, bits, just so that we can remember this, is always going to be zeros or ones in those two numbers. So really, this question boils down to how often do you capture these measurements of audio? Well, as I've mentioned here, that too few of these will result in a lack of detail, and it won't sound any good. So what you're trying to do is get a really good representation of that sound. Now, having said that though, if you were to capture too many, the files might be too big, and the computer, it'll just be working quite hard. So it's this like gray area, again, about how often that you take this measurement of audio, and also how detailed of this audio that you get. And what this will go into really are two definitions. The first definition is going to be sample rate. And sample rate is basically how many times that this is going to be taken every second. Okay, so this will get into how many bits of information that we're going to be taking an example of. And the next one is going to be called bit depth. And bit depth is how detailed this sample is, about how much of this rate and how detailed of this is. And again, these two words, sample rate and also bit depth, are very important. So let's just give you a visual of this. This is an analog, and notice how that this sine wave is perfect. There's no distortion in here at all. And this is, let's just say that this is a Moog synth or whatever it is. That analog is going to be now transferred into a digital. Now notice how in this, what's happened is that it's taken this waveform here, and basically what it's done is that it's taken a snapshot every time that this waveform hits one of these lines here. So as you can see, it's just taking a shot of every time it sort of intersects with this. Now, with this, there's not a lot of information here. So you can see that between all these like little circles, it doesn't really represent, and I'll do this in red, it doesn't really represent all these little lines here, does it? So there's a lot of things that aren't being recorded in this. Now, if you take a lot of snapshots, what you're going to be getting on this is much more detail about this. The downside to this is, again, it's going to be a big file, and also that your computer is going to have to be working a lot. But the good thing is as you can see here, I've got a lot of information being sent into my computer, which is going to be a much better representation of this sine wave. So increasing the bit size and the sample rate, this boils down to one thing: accuracy. This is very important. Basically, the more accurate of a representation that you can get, basically with this type here, it's going to be closer to the actual audio that you're trying to sample in a digital domain. This is a lot of information, and you should pause this and have a quick look over this. I don't think you're ever going to be asked this amount of detail about what happens with a distortion sound. But if you are, just go through this using a DAW, sample rate, and also bit size. But again, I'll be going into more detail about that later. So moving this into Ableton, I just wanted to have a quick look at an instrument called the Redux. Now, I won't go through all these definitions, but you should pause this video and just have a quick read through this. But basically what producers found is that they wanted to emulate that sound that they were getting within analog equipment. In this sense, what they were doing is that they were trying to degrade this sound by either messing around with the bit depth or the sample rate. And this was called downsampling. And basically what this is that you take this rate and you just lower it. So this is how much the rate ought to be. And if you now pull this rate down, it'll start to pull away that sound. The same thing goes if you want to reduce the bit rate. Well, this is called bit crushing. And in here, these 16 bits that you can reduce this down to 8 or 4 to 2. Be aware that if you reduce this down anywhere, I think below maybe 10 or 8, it's going to be quite noticeable about this sound. Again, I know this is a lot of information. Pause this and just read and write down what I'm trying to say here. This is simply giving you examples about using distortion. So let me just go through each one of these. Distortion can add warmth to your individual sound. And we talked about distortion on the lighter sense being in saturation. So you could add a bit of saturation to your sounds. You could also use distortion for certain character. So for example, if you wanted to have a distorted synth or a female vocal or whatever else, so you could do this based on a certain decade that you're trying to emulate. The expressiveness, so intentionally distorting like a vocal part, for example. And last but not least is how to emulate distortion to get a certain sound. And again, I've mentioned here about Hendrix. Now, within this, what is very important that you are able to remember from this lecture are all these key words. You will be asked about this on tests, but also after this lecture, and I'll be expecting you to be able to use these keywords to your advantage.